We're going to wrap up section 2.3 with this information. We have just a little bit left to go. I know there's been a lot of information in section 2.3, and I'm taking it kind of slow because there are so many important concepts in here that will help you be successful as we continue on in chapter 2 and further on in our other sections. Okay, so let's take a look at the average rate of change. Don't let that scare you. Average rate of change is, and let's see if you recognize it as something we did previous. So it says if I have 2 points, x1 f of x1 and x2 f of x2, let's let those be 2 points on the graph of our function. Then the average rate of change is given by this formula. F of x2 minus f of x1 over x2 minus x1. Do you recognize this? It's just the slope. We're just using the fancy function notation for the y values. Instead of y2 minus y1, we're using the fancy function notation. So really, this ordered pair is just x1 comma y1, and this guy is x2 comma y2. That's it. So all we're doing is finding the slope, y2 minus y1 over x2 minus x1. And you can find slope. You did that earlier. So this is not bad. Just remember, average rate of change is the same thing as slope. Now, all we're doing is finding the slope of something called a secant line. I'll explain what that means here in a second. So let's suppose I have an equation, x cubed minus 3x, and I want to find the average rate of change, which is another name for slope, from x1 equal negative 2 to x2 equal negative 1, and then again from x1 equals 0 to x2 equal 1. All I'm needing to do is find slope. And what do I need to find slope? 2 ordered pairs. So really, all I need is the ordered pair x1 negative 2 comma y1, and I have x2, which is negative 1 comma y2. But I don't know my y1 and my y2s. Well, they gave me the x values. All I need is to find those 2 ordered pairs. Finish up those 2 ordered pairs. And what's nice is I have this graph right below. So let's look at our graph to find those 2 ordered pairs. Aha! Negative 2, negative 2. And the ordered pair that goes with negative 1 is negative 1 comma 2. Guess what? You've got everything you need to find the slope. So 2 ordered pairs, I found them from my graph. They told me what x values to work with. And here's where that secant line thing comes in. Notice the entire graph is a curve. Because the entire graph is not a straight line, what I'm going to do is focus on the 2 points they asked me about and find the slope between those 2 points from this secant line. So a secant line is just a line drawn between the 2 points you want to find the average rate of change of. That's all. We've got the ordered pairs, we know the formula, so I can find the average rate of change from x1 equal to negative 2 and x2 equal negative 1 by calculating the slope. I got my 2 points. Let's calculate the slope. So y2 would be negative 2 minus y1, which is 2, over x2, which is negative 1, minus x1, which is a negative 1. I get a negative 4 over a what? A negative 1, so that gives me a positive 4. All this means is that the slope between these 2 points is positive 4. That's all we're doing. That's the average rate of change. On average, it changes 4 units for your rise and 1 unit for your run. So why don't you pause it and find the average rate of change for the next 2? when x1 is equal to 0 and x2 is equal to 1. Is that what we had, 0 and 1? Yeah. So pause it and find that. You should get the average rate of change, or the slope, basically to be -2. So we're looking at these 2 points, and we're checking out the slope of that line. And that's a falling line. The slope is negative. It makes sense. So that's just very easy ways to calculate something that sounds complicated, which is called the average rate of change. Now let me show you how you could do that on your calculator if the graph wasn't given to you. So let's go to y equals, and let's type in that graph. X cubed minus 3x. I can graph it, which is fine, but I want to go to my table feature. Whoops, where's my table? Here you are. And I just want to find those ordered pairs from my table. So it said an x value of -2. So I would look on my table. I'd have an ordered pair, -2, -2. So I'd write that one down. Then I would say an x value of -1. So I would write down the ordered pair, -1, 2, find the slope. Then x1 is equal to 0. I'd have an ordered pair 0, 0. And x2 equal to 1, I have the ordered pair 1, -2, find the slope between those 2 points. So you can use your calculator to find those points if they're not given to you. So average rate of change is just slope. So let's check out a couple of applications. So let's check out this last problem for this section. We're going to use our calculator to work this application. So the amounts in billions of dollars for the U.S. federal government, the amount the U.S. federal government spent on research and development for defense from 2010 through 2014 can be approximated by this model. So we're given an equation, a function, to represent this spending. Okay, in this model, t represents years, the year, with t equals 0 corresponding to 2010. And we want to look at this from 2010 to 2014. So if t equals 0 represents 2010, what would be the value for t to represent 2014? 4 years later, so t equal to 4. So let's work on graphing this model, but we want to make sure t is basically our x values. When we graph it, we want to start with x equal to 4 and start at x equals 0 and stop at x equals 4. We just want to look between the years 2010 and 2014. So let's go to y equals. So we type that in to y equals. And if I graph this in my regular window, Zoom 6, I see nothing. So what we need to do is adjust our window. So let's go to the window. And our x values, remember we said we want 0 through 4, 2010 through 2014. So we only want to look at that window. Now for your y values, let's just graph it, see what happens. So notice I'm between 0 and 4, but I still don't see anything on my graph. So I need to now adjust my y-axis. Let's go to window. And let's come down here to my y-max and y-min. Let's let the y-min start at 0. And let's make the y-max go high. Oops. Let's go 100. So I start my x at 0, it's going up to 4. I'm starting my y at 0, and it's going up to 100. That 100 is arbitrary. I just want to get a picture in my window. Aha, I found it. So this is the graph. From 2010 to 2014, look at the spending. It looks like that spending is decreasing. Let's see. first part of this was to graph it. All right, so we've got our graph. Come over here, click OK, and there's our graph. Did you do that? Okay, well, there's a tiny graph. Now what we want to do in part B is find the average rate of change. What does that mean? We want to find slope. And we want to find the slope between 2010 and 2014. So remember, for those guys, t was equal to 0, and for this guy, t was equal to 4. So I need the ordered pair 0, something, and 4, something, because remember, t is basically our x in this problem. Let's find those ordered pairs and calculate the slope, because when we do that, we will have the average rate of change. Yay! So let's go to our graph and find those ordered pairs. So I'm going to go to my table. And at 0, it is 95.08. So there's one ordered pair. Let's find the ordered pair at 4. $70.534. That's a little messy. So I have an x value, I have a y value. Notice what I did. I just went to my table. X value of 0 corresponded to 95.08. X value of 4 corresponded to 70.534. Now we can find the average rate of change, which is the slope. Find the slope, pause it, come back, see if your answer matches. Okay, so I worked it out and got an average rate of change of negative 6.1365. And that is a negative slope, and if I go back to my graph and look between here and here, that slope, that secant line, is a falling line, so it's got to have a negative slope, so I think I'm probably on the right track with this. Well, I hope these videos are helpful, and please contact me if you have questions on any aspect of this course.